Hello and welcome back to another episode of Math with Stone. Today we're going to be learning about probability and the addition rule and mutually exclusive versus not mutually exclusive. So let's get into it. As we continue, we are going to learn about these two formulas that are used for not mutually exclusive. But if it is mutually exclusive, it would just be this part, okay? So if they happen to be mutually exclusive, you just add them together. If it's not mutually exclusive, you would have to have the whole thing. They are the same exact formula, by the way. So this U means or, excuse me. And the upside down U, meaning intersection, means and, okay? So what is mutually exclusive versus not mutually exclusive? Well, mutually exclusive cannot happen at the same time. They cannot happen at the same time. Versus not mutually exclusive can happen at the exact same moment. Okay? So if you have two cards drawn from a standard playing deck, one is an ace or one is a spade, we're not finding the probability of this. We are just determining if it is mutually exclusive or not. Well, can you have an ace that happens to be a spade in one exact moment? And the answer to that is yeah, the ace of spades. So if that is the case, then this is not mutually exclusive. Okay? And that would mean that we could, for a singular event, use one of these formulas. A nickel and a dime are tossed. Is it possible to get a heads or a nickel? So is it possible to get a nickel that happens to land on heads? And the answer to that is yes as well. So this would also be not mutually exclusive. I abbreviate because mutually and exclusive are big words. Last one, we got a box of 5 markers. One is blue, red, blah, 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 blah. Is it possible in one singular event to get a green marker and a red marker if you're just picking one marker out? And the answer is no. This would be considered mutually exclusive. You cannot have a red-green marker. Well, not in this case. They do make markers that are both red and green, but it's kind of like two markers put into one. Let's do some actual probability with it. We're starting with some yogurt, and they made a nice little diagram over here that I'm going to have to scroll back and forth. My wide view camera is not that wide. Each time a customer at a frozen yogurt shop orders either a cup or a cup of yogurt, the name of the customer is written on the slip of paper and placed into a box. At the end of the day, the shop manager selects a name from the box to give a free frozen yogurt. That's kind of nice. How do they contact you, though? On Tuesday, the winning customer had purchased a blueberry yogurt or a large cup of yogurt. Okay, so it doesn't even ask us to figure out the probability, but I guess that's the idea. On Tuesday, what is the probability? The winning cup, the probability of the winning cup is a yogurt or a large cup. So a blueberry yogurt happened with all 3 of these, and the large cup happened with all of these, including the 4. But you notice how I didn't wrap around the 4 again? You can't count that twice. In order to find the probability that it is a blueberry yogurt or a large cup, you would be adding all 3 of these and all 3 of these, but you don't want to have the intersection, which is what this formula is all about. You add each event, but you would have to take away the overlap. Okay, so you don't want that to actually be included, and that's why when I did this, I didn't include it. But if you did include the 4, you would have to subtract it at the end. Okay, so we're going to add up all of those. 14, 4, and 2, that makes 20. Plus 4 is 24, plus 7 is a number. 24 plus 7 is time for my calculator. It's too early in the morning for this. 24 plus 7 plus 15 is 46 out of the total. The total would require you add all of these up. The 14, the 2, the 8, the 12, the 4, the 7, the 15, the 2, the 3, the 10, and the 9. I'm tempted not to do it out of the sake of speeding up the video for you guys, but I'm doing it real quick. It is out of 90, which could simplify if you need to. So that is the probability that the winning cup was blueberry or a large cup. All right, so here we're done with probability. We're still just going to figure out is this going to be a mutually exclusive or not mutually exclusive. This one right here with the yogurt was not, because you could have a large cup and blueberry at the same time. Is it possible to purchase milk and bread at the same time? And the answer is yeah, that is not mutually exclusive. You're going to find out that most things are not mutually exclusive. On a sunny day, you go outside or go to the park. Is it possible to go outside and go to the park? Yes. Although that is kind of funny because it's impossible to probably go to the park without going outside. But it's still not mutually exclusive. A randomly selected day of the year is either in January or in March. Is it possible to be in January and in March at the same time? No. That means that these would be mutually exclusive. You cannot be in January and in March at the exact same time. All right. Let's see what other ones we got. Here we go. Here we go. Some more. This one's going to be starting probably some probability here. Water bottle. Caleb purchases a new water bottle and sells at the store, blah, blah, can't remember. Yeah, probability. So the store sells 3 shades of red, light, and a dark green. Got to read that again. The store sells 3 shades of red, light, and dark green. What the heck? I can't read. I'm moving on to a different one. They're selling a water bottle. Is it 3 shades of red, a light, and okay, so it's 3 different shades of red, a light green, and a dark green. That made no sense to me at first. So they got 3 red, a light green, a dark green, 3 blue, a gray, a pink, and an orange bottle. They couldn't have worded that worse. You can tell this was written by math people. If Caleb chooses randomly, what is the probability that he will choose either a blue or an orange? Now, a lot of these, even though you do have these fancy formulas, won't need them in a lot of scenarios. So, how many of them are blue or orange? Well, there is 3 blue and 1 orange, so the total to that would be 4 out of the overall total, which would be 3 red, plus 2 is 5, plus 3 would be 8, plus a gray would be 9, plus a pink would be 10, and plus an orange would be 11, so it is 4 out of 11. One more like this. I think this is a little too easy. In class, 26 students, 18 of them have a pet. Of the pet owners, 12 prefer dogs to cats, 8 are non-pet owners, and 3 prefer dogs to cats. What is the probability of selecting a student from class who is a pet owner or prefers cats to dogs? So how many owns a pet or prefers cats to dogs? Well, is it possible to own a pet and also prefer cats to dogs? That would 100% be possible. You would have to own a pet to prefer cats to dogs. No, you could potentially just not own a pet, but still prefer cats to dogs. So let's see what we got here. We got 12 prefer cats to dogs. And we have 18 that actually have a pet. Some of these 18 are probably going to prefer dogs to cats, but we misread it as cats to dogs, so we got to use the 3. Some of these 3 that prefer... Does it say? Is there another typo? It says 12 prefer dogs to cats, and then here it says 3 prefer dogs to cats. They made a typo. I'm assuming most people prefer cats to dogs, so I'm going to say the 3 is the prefer cats to dogs. 3 cat to dog. Man, this worksheet. Textbook people. Get it together. There's a few things that you could do for this, but you have to first determine that these are not mutually exclusive. So we are going to use the formula. We're going to add up each of them and then take away the and. Okay? So is there an and given? That's the main question. Not immediately, but you can get the and by multiplying. Okay? So we are going to take 18 out of 26 plus 3 out of 26 because they messed up the question. But then we will have to subtract the multiplication of both of those. So this is the formula trick when you don't want to have to draw a diagram. You could definitely draw a diagram and it would all work out, but this is the formula trick for that. So we can do that math. We got fraction 18 out of 26. Add them together, then subtract the multiplication. So 18 out of 26 plus 3 out of 26 minus the same thing. I wish there was a copy and paste button. 26 times 3 out of 26. Calculator would have been nice if I had it on the camera. Equals 123 out of 169. So you just use your calculator, you get your answer, you call it a day. 123 out of 169. All right, I got one more because I feel like we need one more. I'm going to pick a random one from the last page. I like 12. It's using percentages, so that's kind of nice. On a math exam, 36% got an A. 28% got a C. What is the probability that a student in the class got an A or a C? This one is way too easy because it's actually mutually exclusive. Can you have an A and a C on the exam at the exact same time? No, which means you don't need the whole formula. You only need the A and the B added together. So if you add 36 and 28 together, 36 plus 28, you get 64%. Perhaps we should do another one. That was a little too easy. That one's not, that one also mutually exclusive, so I don't want to do that one. All right, cards. Not everybody likes cards. A card is randomly drawn from a standard deck. What is the probability that the card is either a face card or a spade? You could have a face card, jack, queen, or king, that happens to be a spade. So this is a good one to finish it off and to use the formula. So what is the probability that it is a face card? Well, there are 1, 2, 3 face cards. They're not counting an ace as a face card. And that would mean if there are 3 of them in every single suit, there are 4 suits, there would be 12 total face cards. There are 13 total spades. So we would have 12 out of 52 and 13 out of 52 for the spades. Because you could have a jack of spades, these are not mutually exclusive, we have to use the formula. Either one of these, they're the same thing. So we have to add them and then subtract, multiplying them to get the answer, multiplying them. So it's always important to identify if it's mutually exclusive first, and then you type in the values. So, typing in the values, we have, I'm going to type it over the previous one that I just did, 12 out of 52, added with 13 out of 52, minus 12 out of 52, times 13 out of 52, is, bink, 11 out of 26. And to kind of further in why that is again relating to the table. Some of the overlap is there. You can't count it twice. Until next time, stay positive. This is probably one of the longer probability videos, so I appreciate it if you watched all the way through and subscribe. I will see y'all in the next one. Bye.